Yeah, when I in a moment. Okay, so great. Thank you very much for coming along, everyone. So SQLite, could you click on the other thing? So we are going to be live streaming through Google Hangouts on air. We don't get many people listen to it live. We like to put it on our YouTube site so that people can go and look at the presentations afterwards. So a quick introduction to databases and why you might want to use them. So in mobile phones, there's basically 4 ways that you can store data persistently. One is user preferences, which is really designed for little bits of information, you know, user information, user preferences, really. All 3 of the platforms that Xamarin supports offers this feature, but it's very limited. You could use files. So you know, and often you will use files. You know, if you've got large amounts of atomic information, you can use files, use it in the local file system. But obviously, they're unrelated to each other. There's no way of sorting the information within the files. You end up with lots and lots of different files if you have lots of information. Then you have databases. You can use a local database to store related data. In tables, allowing fast access, allowing you to retrieve data that meets specific criteria. And then you could also obviously use a cloud or web service to store information on, and depending on what service you use, it could be using you know, blobs in the background, basically files, or it could be using a database in the background. Just depends on the service. But obviously, you know, that has an advantage that in that it's going to use less resources in terms of your local memory, but it is going to take more time because you actually have the transaction of data across the air. It's going to use up the user's bandwidth, and it's only going to be available when you're online. So if you need something offline, that's not going to be suitable. But basically, if you're going to want to locally store any persistent data, you're pretty much going to need to use a database. So what is a database? Well, databases store data in tables, and those tables have fixed columns that have a specific data type, and the columns are obviously named, and then data is placed in those tables in rows. So basically, it looks like, think of the table as an Excel spreadsheet. And each table is like its own Excel spreadsheet that you can sort through. Now you can use a column that's shared between 2 tables to relate information. So for example, you know, if you had customer information and you had a customer ID and then you had another table with order information, you might have customer ID in there as well, so that you can relate the 2 things, 2 sets of information together. Now in a relational database, tables can have 1 or more indices or indexes. Now, indexes are special data structures that provide an abstract way to quickly search through the contents of a column. So you can ask for, you know, quickly go through the column, ask for specific records that match the criteria you want. And if you define them, the database engine will automatically use them. You don't have to say use the index; it will automatically get used by the database engine. And each database engine, each type of database has a different way of doing that. So you don't really need to, unless you're a real power user, you don't really have to really understand how the indices work or what they're doing in the background. Then you have keys. Now, keys are special lists used by the database to identify rows and relate records in tables and enforce constraints. So you have a primary key. Now, each table will have a primary key. And the primary key is used to uniquely identify each record in a table. If you don't specify a primary key, what will actually happen is the database engine will actually will create one in the background for you. With SQLite, there's a thing called row ID, and it's a column that exists on every single SQLite table. And if you don't specify a primary key, it will actually assign one to row ID for you, even though you don't know it's done it. It has to. It has to be able to do that because every single record must be unique in some way. And then tables can also have things called foreign keys. They're used to enforce constraints between related data in different tables. So a few tips, this is sort of database 101 type stuff, but use meaningful names, use meaningful database names, table names, and file names now, and field names. Sorry, I know that sounds obvious, but you'll be amazed how many people sort of try and shorten names, make them difficult to read, which is terrible for maintenance, because somebody else comes along, tries to figure out what you've got stored in the table or how it works, and then they're going to have difficulty doing it. Model the database. Unless it's a really simple database with like one table or two tables and that's it, actually model it with an entity relationship diagram. They look a bit like class diagrams for OO, but it will really tell you what's in the tables, what needs to be there, is there anything in there that shouldn't be there, should you need another table, what the relationships are. It will actually really guide you as to how to use your database and how to structure it. And a picture paints 1,000 words, and you'll be amazed how useful it is. And the other things to avoid what's domain pollution, or what's sometimes called make the database orthogonal and normalized. And basically what that means is that any table should only store groups of intrinsically related data. So if 2 bits of data in there basically have no relationship, they're not part of the same entity, they shouldn't be in the same table. There's 1 or 2 exceptions. You might use something for convenience, but on the whole, that's the rule that you use. If you see that a table only has only one-to-one relationships with other tables, you should always ask, does that information need to be in its own table, or should that data actually be in the other tables that the relationship's in? Because there's very rarely a case where you actually have one-to-one relationships that are meaningful between tables. Unlike with OO, where it's perfectly acceptable. And that often happens if you're from an object-oriented background and you're designing a database and you design it as if it's a class model. And you'll find those things sort of tend to creep in, so you have to keep that in mind. And obviously, tables shouldn't have duplicate fields, shouldn't have duplicate columns, because it's a waste of information. And again, people get lazy sometimes, and they do that. You should always set one column to the primary key to uniquely identify each record. As I say, SQLite will actually set its own row ID as that if you don't. But generally speaking, you're going to want to be able to uniquely identify things. And a primary key can actually be more than one column. It doesn't have to be a single column. You could say these 2 columns combined will always be unique, and define it that way. Tables often have, we mentioned that. Numeric keys, thing to bear in mind, numeric keys and indexes are faster than text or any other type. So where possible, always use a primary key that's a numeric field, a numeric column as a primary key. And where possible, use put indices on numeric columns, and if necessary, consider using abstract IDs to represent data in order to be able to do that, because it will speed the database up very, very considerably. Try not to duplicate fields across multiple tables, except in the case of a foreign key. Always ask, if you've got the same information in 2 tables, for example, customer ID, ask why it's there. And if you're not actually going to be using it to look up information, it probably doesn't belong there. You probably shouldn't have it there. And if it is there, you should probably create it as a foreign key. So not only index it, but actually create it as a foreign key as well, and say you can only have this value if it exists in this master table. And then reference data in other tables via the primary and foreign keys, so that you can actually manage and control the data. Right? But it is easy to overdo it and put a lot of work into that sort of thing when it's not really necessary. So, you sort of have to take everything, use your own judgment as to how far along those lines you go. Now, some denormalization is acceptable if driven by performance considerations. So, for example, you might have a very large table with certain information in it, and that might just be too slow for you, and you might want to take some of that information out and put it in a different table, which will give you faster access to some of that information. But it's risky because now the two things can get out of sync. So if you do that, you should use foreign key constraints to enforce the data integrity. And then when you should create abstracted access mechanisms. So in your code, have something that says, hey, if you're going to insert something in here, it will also automatically get inserted here. If you do something to the information on one table, we will automatically do it to the other one. And that's obviously a coding problem that you just have to do. Your application should never alter the database schema, only the database it holds. So while the database is running, you should never be on the fly creating tables, creating relationships between tables, changing table names, adding columns, all those sort of things. There is one exception to that, and that is when you're initializing the database, when the app starts up, or if you're upgrading the app to use a new version of the database. Under those conditions, you're going to have to do that, obviously. Another thing you should do is avoid using some certain design patterns. There's one called the common lookup tables. Common lookup table, and what that is where you have unrelated information, where one of the columns says the information one of the columns defines the type of information in another column. And people do that sometimes because they think, oh, I can do that because I can save tables. Well, in a database, that really doesn't gain you very much, and it just complicates things and will actually slow things down. You can also get a thing called the entity attribute value table, where you have separate columns for each attribute. So you'll have too much information, if you like, in a single row, instead of having multiple rows with some of the information is the same and some of it's different. And then data as elements is another one that you see quite often, which is very bad, and that is where you actually have fields or even worse, tables which actually define elements. So, for example, you might have sales records and say, I can have a table that's going to be January 2015, and another table that's going to be February 2015, and another one that's going to be March 2015, and every time there's another month, we'll create a new table for that. No, you should have it in one table, and each record tells you what year it is and what month it is, what the date relates to, so you can sort through it properly. And then enforce data integrity across the table. Again, you could do that through. You don't have to do that through the database. You could actually do it in code, but the facility's there, so it's a good idea to use it. Okay, SQLite. So that was sort of general stuff. So what is SQLite? Well, SQLite is a small database. It's about 350 kilobytes. That's all. It's lightweight, and it is a relational database. I sometimes hear people say, well, SQLite is just flat files. It's not relational. It is relational. But what it does, it stores everything in a single file. So each database will have its own single file that defines everything about it. And that is different from most relational databases, or they'll have multiple files for a given database. So it contains both the pragma information, which is the structure of the database, how it's configured and everything else, and the data which is stored in it. Now, writing causes file locking. So writes are always sequential and blocking. Reads, on the other hand, can be multitasked. So if you can have multiple reads on the same table happening at the same time, you won't get any problems. That's fine. SQLite allows you to do that. But the minute something starts writing to it, it will lock everything out of that table. It's designed for local use. It's not client server. Most databases, we use the client server databases. But this isn't. It's designed to be local, where the client, if you like, is all on in one place. But what that does is it means it's ideal for embedded and mobile devices. You know, it's lightweight, it's small, it's actually pretty performant, and it doesn't need a client server architecture. It's open source. That's great, because not only you can check things out to make sure, you know, is it what it's doing if you need to, but you can customize it if you want.
It's fun to say, it's more than open source, it's absolutely free.
And it's free, of course, yeah.
I mean, what I'm saying is it's public domain, so you can make changes to it, necessarily make the changes. It's, you know, free.
Yeah. In fact, a couple of years ago, I was speaking to a company that at an event, and they were showing off something they'd done, and they'd used SQLite, but because they were using so many records in the table, it wasn't performant enough for them. So they actually rewrote some of the access mechanisms to suit their specific application, the specific use of it. And they were able to do that because it's open source, and they could actually get all the source code. And then they included it with their distro. It's ACID compliant. Everything it should be. So atomicity, consistency, isolation, and durability. It stands for, if you don't know, but it meets those criteria. It uses dynamic weak data types and syntax. So what that means is that an integer, you don't have to specify how big it is. You just have to say it's an integer. It will work out how much. It will actually work out how many bytes to allocate to a particular data type based on your host operating system. And it uses the SQL query language. Actually implements most of SQL 92. There's one or two things it doesn't. For example, it only partially supports alter table and only partially supports triggers. If you're not going to use those, not a problem. But if you are, you just have to be aware that they are limited in SQLite. And it's performant. I've actually heard people say, well, problem with SQLite, it's not performant. It is. Typically, it's about comparable to MySQL, and there's a lot of companies use MySQL out there on servers, and SQLite is as fast as MySQL. Most reported errors and problems with SQLite tend to be related to incorrect pragma settings. So basically not having set the database up correctly, rather than actually problems with SQLite itself. And performance tweaks are possible to suit a specific use, and I'll go into some of those later at the end of the presentation. Now it's available on multiple OSs. In fact, it's available on almost all OSs, that are popular ones that are out there. As far as mobile is concerned, it ships natively on most of them, with the exception of Windows Phone. So basically, just about any mobile platform you can think of, they ship with SQLite as a shared resource, but not Windows Phone. Hopefully that might change soon. Microsoft have made things a lot more friendly now. It used to be that you'd actually have to go get the libraries and compile it in and build it into your project. But now you can actually include it as an extension to Visual Studio, and you just go and get those. One issue this does create, though, is the version of SQLite can differ between platforms. With iOS, it tends to be related to each of the OS version, though they tend not to change it that often. They tend to change every 2 or 3 OS releases, and they update it. Android, on the other hand, like a lot of other things, it's the Wild West. Not only can it be different between the different versions of the OS, but it changes by manufacturer, because it's not defined by Google as part of the OS. So, you know, if you're running KitKat on Samsung, it might be on and not just, it could be the model. Because even with Samsung, one Samsung model could have a different version of SQLite than another Samsung model, where both of them are running KitKat, for example.
I mean, Nexus device would have to have SQLite installed.
Yeah, Nexus is slightly different because although it's different manufacturers, everything about it is specified by Google. Okay, so Google will be the ones that will specify which version of SQLite. But there's only ever one Nexus device for an operating system. So you're never going to come see that situation where you see, there's only one Nexus 5, there's only one Nexus 6. So, and each one is designed to use a different operating system.
It's not necessary to install it.
Oh no. It's part of the standard. Google says it must be if you install Android and sell a device with Android on it, you must embed SQLite in there. Exactly. And typically speaking, if it's a modern phone, you're not going to have too many problems. There were some issues, really, mostly with Android phones that are pre 2.3. There were quite a few SQLite features that on some manufacturers weren't available, and that's where you can get some problems. And occasionally it's a little bit worse because it's open source. I have heard of Samsung in particular will tweak the way SQLite works for their phones, which can break things sometimes. So it's just something to bear in mind with Android. As I said, with Windows Phone, Windows Phone always tends to use the version. Well, it will always use the version that you installed in Visual Studio as the extension, and they are pretty up to date with that. In fact, they recently put an extension update out, so it's now 3.8.9, which is the latest version of SQLite. Sorry? No. Well, said that if you built it in, if you had your own distribution of it, a device could have its own SQLite, and you could package up your own version of it as part of your application and install it on there, and it's going to be using your own local copy of the SQLite engine. So there's no reason why you can do that, but you won't find a common version of SQLite available. More than one version available on a phone as a common. So I didn't quite understand.
You have an SQLite version that's with your app and then but it's already on the phone, somebody else's app earlier.
Okay, so what happens with iOS and Android? You'll be using the SQLite engine that comes with the phone as part of the operating system. Okay? With Windows, it gets packaged up with it. So if it's packaged up with it, you're not going to get a conflict because it's sandbox. It's just part of your application. And similarly, if you actually said no, I don't want to use what's on the phone, for whatever reason, I'm going to package up my own version of SQLite as part of my application. Again, it will be sandbox, so you won't have a problem.
That's what I was trying to find.
Oh, right.
Is that you could on the phone, your OS could have version 3 installed. I could install that. It packages up version 3.2, and you could target version 3.1, package up the version.
Yeah. So anyway, so SQL is also weakly typed. So it basically it maps different primitive data types onto its own weakly typed primitive types. Okay, and uses variable length storage to handle the different sizes of that data. So in theory, you don't have to worry too much about typing. SQLite will handle almost everything in the background for you. So it really only has 4 basic data types that it supports. Text, which is basically strings. Integers, which are basically bytes, integers, shorts, and longs. Reals, which are basically floats, reals, doubles, that sort of thing. And then blobs, which is basically a byte array of data. Now, it's actually very forgiving. If you put text, you can actually do things like write text to an integer in SQLite. I would not recommend it because you don't quite know. There are rules. The SQLite Foundation actually defines how it does that and what it's going to do and what the mappings are and how it decides to handle that sort of thing. But they're a little bit confusing on why would you do that? I mean, it's a good idea. You want to be able to go back to it and know what it's going to do. So you shouldn't really do that. Map it onto one of these things. It calls those affinities. There are a few things where you might want to use your own conversions. And the two common ones of those mappings that you might want to use are Booleans, and actually map a Boolean to an integer, make it a 0 or a 1, because that way you know exactly what it's doing at any given time. And the other one is date. And again, I would always recommend, dates are a nightmare, especially when cross-platform. So my recommendation for handling dates is to always map it onto an integer or a long value and use the same standard in your application all the time. Because Microsoft uses one format, Android uses another, or Java uses another. It can be, and then God knows what Apple uses. So why not make sure you convert it. If you store it as long, you know that you can get it in there and get it out, convert it back to a date. You're in control. So now I'm going to talk about SQLite PCL. So one of the great things about SQLite is not only is it cross-platform and everything, but within the Xamarin family, there are a number of portable class libraries that support SQLite. I'm going to be talking about one particular one, SQLite PCL. There are others. SQLite.net is a very popular one. And really, these two are the two most popular ones. There's various others out there as well, but these are the ones, those are the two that you should really consider using. So what SQLite PCL does, it provides a constant cross-platform SQL interface into SQLite. It's not an ORM. SQLite.net is an ORM. So it basically uses objects to map things in and out. You don't have to write any SQL. SQLite PCL, you write SQL. And you're writing SQL statements, which I love because it means that it's easy to debug, and it has a huge advantage of there's a lot of information out there on Google, on the internet, on Stack Overflow about how to do things using SQL. Right, that's not necessarily available if you're using an ORM-based approach. It also closely mirrors the SQLite native C++ API, so it's very, very fast. However, because of that, there's one or two things that aren't completely obvious at first, unless you've actually used SQLite using C++. It's synchronous. This PCL is synchronous only. And with any sort of data access on a mobile device, synchronous is a bad idea. So you're going to have to implement your own asynchronous versions of methods, so that you don't block the GUI thread when you're accessing the database. There's another thing you have to do with it. You've got to reference it from the main application projects for each platform, because there's a different, effectively, because of the file system being different on each platform, because it has to access it behind the scenes. You need to tell the PCL which platform it's actually running on, so it knows which set of dependency injection to use. And you do that by referencing it in somewhere in the application project, normally when it's launched. And in iOS, you actually have to initialize it as well. And if you don't, you will get build errors or occasionally runtime errors. So you add it to your project via NuGet. So it's called PCL storage. Oh, sorry, that's not called PCL storage. That's a different one. Sorry, it's called SQLite PCL. There you go, bug in my slides. The current version, and that version is wrong now. It was 3.8.7.2. It's now actually 3.8.8.3. And it's Microsoft Open Technologies. So it's actually managed by Microsoft, which is great because you know it's going to be updated. You know it's going to be maintained. And currently it supports Windows 8.x Universal Apps, Windows Phone 8.1 Universal Apps, Windows Phone SQLite, so 8 and 8.1, .NET 4.5, Xamarin iOS, and Xamarin Android. There is one thing to mention. I might as well mention it here. It's always going to be referencing a particular version of SQL. So the current version that's available for SQLite PCL is 3.8.8.3. So it's expecting to be interfacing with SQLite 3.8.8.3. Only they've updated it to 3.8.9. And when you go into Visual Studio, it will say, hey, there's an update to SQLite. Do you want to install it? Yeah, absolutely. I'll update my extensions. Bang, your project won't build anymore. And you can't undo it. It's really difficult to undo it. So that's a bit of a problem. But there is a way out. And that is what happens when you update Visual Studio updates an extension. What it does is in the extension folders, if you go through, you can Google how to find where it's going to be stored. But under SQLite, you'll see there's a version number. And what it does, unfortunately, it deletes the old one. So it installs a new version, deletes the old version, and that's why you're going to get build errors, because it can't find SQLite. It can't, because it's expecting to see it in a particular place. But what you can do is just create a folder with that version number, copy the new version into it, and it's going to start to work. So, you know, unless it's there's a big, huge difference where there's something you're going to be using where the API to change, but that's going to be pretty rare. But it will get you out of a hole when you do get out of sync, which you will. Trust me. And I believe that's a problem on SQLite.net as well.
Response queries, what sort of format does it use for response? Is it an object? Is it JSON?
Sorry, for what?
Response to SQLite?
So I didn't.
How does it respond? Is it using a data adapter or a data set? When you make the query, how does the data come back?
Oh, it comes back in a structure, and I will be showing you that it comes back in a particular object. So basically, you create or open a database using an instance of SQLite connection, and it's really easy. You just put SQLite connection equals new SQLite collection with a relative database path. And now this location is relative to the default locations used for the platform that it's running on. Okay, and it must already exist. It won't create its own folders to put things in. Not currently, anyway. So if you specify something and say, hey, I'm going to want to put it in my own special folder that I've called something, and you haven't already created that in the file system, it will throw an exception. Now, the relative path can include subdirectories, or you can even go up a level. So if you use the double dot, you can actually say, go up a level and go down the tree, the directory tree or folder tree, down a different way. So these are where it puts it. So for Android, the default location is basically the files folder. Now, anyone that has used Android knows that, well, normally you put it in the database folder. If you use SQLite on Android natively, it will put things in automatically put things in the database folder for you. It will create that database folder for you. It doesn't exist naturally. So SQLite PCL shoves it in the files folder which it knows will exist. In iOS, it will put it in the documents folder for your app. And in Windows Phone, it'll put it in the local folder for your app. Now, one thing to notice, one thing just to bear in mind on iOS, that documents directory, that documents folder is accessible by the user, and it can be accessible by other apps as well. So if there's sensitive information in your database, you might not want to use that. You might want to tell it to use the library. I've actually raised it to these guides as something they should consider doing anyway, because it's a little bit insecure the way they've implemented it. So all database commands, all database access commands use this thing, an interface, SQLite statement, and they're going to have this form. So basically, the statement equals the prepared command. You prepare it on the database connection, and you pass it the command, and then you implement it through this thing called step. You run a step on the statement and get the result out of it. And actually what happens when you execute the line, you do the execution, it basically passes back a result, and it's an enumeration, but it also updates the structure of this statement, actually puts the results of it. So if it's a query, you will actually get the rows of information from that query in this object, which you then pull out. So it's simple, you know, you just put your standard SQL statements in there, and it's going to execute them. So say you wanted to update the version of the database, version number of the database, your database, you pragma user version equals 2, and that's all there is to it. You know, if you wanted to insert some data, you just use the insert SQL command, standard SQL, prepare the command, and then run the step. And that mirrors exactly how the C++ interface works. So talking about queries, and how does queries get information back? So what it actually does is, as I said, is that it actually, when it runs the query, you have to run each step. And every time you run a step, when you prepare it, it sort of actually runs the query in the background, and then you basically tell it to step through the results, and it will actually populate it in the statement, in this statement object that you've used. It will pull back a property called column count, which gives you the number of columns that have been retrieved for that record. And then for each of those rows, you can pull out the information, and this is basically how you do it. So you basically step through it until you don't have a result coming back which tells you that it's a row. It'll come back with done or okay or something, and then you can terminate. So while it's come back with a row, pull the information out. You look at the number of columns that's come back. It should always be the same, but create a list. This is how you can do it how you like. What I do is I sort of do a cursor, and I say it's a list of objects, because then I can put any information, any number of rows in it, and retrieve the information. But basically, for each row, go through the number for each of the number of fields. Basically, pull out of the command, out of the statement. That should say statement. The version, and in this case, I'm adding it into this list. So after I finish that list represents a row of information, and then I add it into the outer list. And that's basically what a cursor is. Okay, so, oh, well, it doesn't have stored procedures per se. It does. You can use prepared statements.
So you've got to roll your own injection.
Sorry?
So you've got to roll your own protection against SQL injection.
Yeah, yes, but you can use prepared statements, which are very similar to stored procedures, and they do give you that protection as well. Sorry, let me pull this up. So I will just wait for this project to load. Are there any questions up till now? Okay. Let's wait for this to load. Oh, I better share.
Can I ask you a quick question?
Yeah, of course.
Why do you prefer SQLite PCL over SQLite.net?
I like it because I like working with SQL. You can do a lot more with it. You can do a lot more powerful queries with if you're writing your own SQL than if you are using SQLite.net.
Organizing your SQL rather than just strings.
Sorry?
Do you have a better way of organizing your SQL rather than just strings sprinkling your .NET code? Or do you just go with that?
Actually, I actually have developed some query builders. So I've done some helper methods that can create where statements, can create insert commands, that sort of thing. So that's how I do it.
Basically, you almost built your own. Yeah.
But that's sort of how I do it. Visual design. Okay, so running on iOS. Of course, there's always a problem when you do live code demos. Is that, so I've got fingers crossed, please run properly and not crash out or anything. Oh, I didn't come up with an iPad. Oh, it doesn't matter. We're not going to be doing it anyway, but we'll run the database test. So the first thing I want to show you is how you can change the location that things are going to be stored in. So I use another PCL. Obviously, you need to manipulate the file system. I use a thing called PCL storage, which is great. It's really simple, really easy. But basically, what I do with that is I look at, I basically look at where PCL storage is going to try and store something, and based on that, I can tell which operating system, which platform I'm running on. So I don't have to be reliant on anything else. And then based on that, I'm going to be changing the location. So in this case, it's iOS. So what I've told it is that I'm going to create something called databases. And it's actually, I'm going to be changing the location. So I'm using this double dot command to go back up. I'm going to put it in the library, into the library folder, and then I'm going to create my own folder underneath it for the databases. And then here, as you can see, I'm creating that folder. So now to create a database, so this database name, we'll just go into there. And you'll see that what we're doing, if you're just creating a new SQLite connection, the relative path is what we've is going to be that the path that we've set plus the database name. So in this case, it's that double dot library databases that we just created, and then the database name is testdatabases.db. And then we just open a new database connection, and I've opened it as a read write. It will do a read write by default. You can specify it. You could specify it as read only. And it's going to come back with a new SQLite connection object, which contains all the information it needs to be able to interface with that. We can check to see if that file exists in the file system, and it does. So say we want to do something like set the version of the database. So let's set the version of the database to 8. So all we do is we use this pragma statement. So pragma user underscore version equals and the version we want to set it to. Then we prepare the statement and step through it, and it's going to set it, and it says, you know, it has set it correctly. So let's read it back. With pragma statements, basically, if you're setting something, you put the statement equals whatever it's going to be, and if you leave the equals out, it's basically just going to return the value that's been set to already. So in our case, it's going to do that. It puts it into a row. Ooh. I'll have to look at that in a moment. Damn it. It's altered all the breakpoints for some reason. Jumps into table created. So here we're creating a table. So the table we're creating is just, and I've basically just done these as strings, so you can see. Create table if it doesn't exist, the employees table, employee number, integer, primary key not null, first name text not null, last name text not null, and a rating, which is going to be a real. Prepare the statement and then step through it. And we then look to see, in this case, we're expecting it to come back with done. And it does. So it's true. And if we look here, what's that database version that we read back is 8. So we can see that it set the database version using that pragma. We'll create a second one. We're going to create a second table here. This time we're going to call it allocated assets. Doesn't matter. We're going to give it an ID, which is going to be our primary key. We're going to give it the employee number, an asset number, and with the employee number, we're going to set a foreign key on it. And what we're going to say is that the employee number in here must always match an employee number in that employees table. And it tells us it's created it. Great. So now let's see what tables exist. So we can run a SQL statement to tell it what tables exist in the database. And we do that by doing this statement: select distinct table name from the SQLite master table. So SQLite master is a table that SQLite keeps, that basically keeps track of the schema information. And that's a query. We're doing a select statement, so that's a query. So we're going to basically go through it and say, for every row that exists in the query, let's pull out that information. And then for each of those rows in the list of lists that we've created, we're going to pull out the information. Now, we happen to know that it's only going to be one row, and there's only going to be one column in there because it's a single value, which we're going to pull out. So we've put it out into a list called tables. And if we look at tables, we can see that it's come out with employees table and this allocated assets table. So that's right. It also keeps in the background this thing called SQLite sequence as well, which is something SQLite maintains. So we can also take a look at the column names. So let's pull out the column names for a table. So we're going to select star from the table that we're going to look at, which in this case is going to be the employees table, and we're going to limit it to one record coming back. Prepare the statement, and we can actually pull back something called column name. The statement, SQLite statement object actually maintains a property called column names or column name, and it's actually an array of strings which contain all the names of all the columns for the columns that were pulled back in the query. So we can just pull out that information, and we will see that we have 4 columns: employee number, first name, last name, and rating. So we can see that that database exists. We can see that the tables have been created. They seem to be created correctly. So let's create an index on something. Create index, it not exists. We can just create an index name on the table for a particular column. Run the statement, and again, it should come back with done, which it has. So it's going to tell us that it's created that index. So let's do something a little bit more useful. Let's insert some information. Let's insert a record. So again, it's a standard. There we go. It's a standard SQL statement. Insert into employees table the employee number, first name, last name, rating, values 2, 3, 5, 4, and 9.6. And we can pull out the thing called last insert row ID. What last insert row ID will actually do is pull out. It's a little bit badly named actually, because it doesn't actually bring out the information for the last. It doesn't actually give you the last row. What it does is it gives you the value of the primary key of the last row. So in this case, we actually said our primary key is going to be that employee number. So it doesn't come back and say, hey, there was no records, it's the first row in this table, so bring it back a 1, which is what you would expect. What it'll actually do is bring back 2, 3, 4, 5, because that's the primary key. Now, if we had created, if we had not specified a primary key, or if we'd specified a primary key as just an arbitrary integer, it would have come back and actually given us the number of the row, the real number of the row. But what it's doing is it's assuming that you're going to use the primary key to try and access something and figure out where something is. So it's assumed that that's the information that you're after. And we can query the contents of the table now to show that it's in there. So we're going to select star from the table name. Yep.
Is that row ID, the system generated row ID, is it generated in all cases or only if you don't have one in your table?
No, it will actually be it exists for every single table in SQLite. And you can access it. You can actually say, call the column that you're going, or the column that you're getting information, row ID, its reserved name. So it's actually accessible to you as well. You can even change what's in there. It's not recommended. So what we've done here is we've pulled it out, and this cursor, this list of list of objects. That's really a cursor. It's equivalent of a cursor. So there's one object. It's got one list, and it has 4 items in it, 4 objects in it, and it's got that information that we put in. Okay, so I talked about prepared statements. So someone mentioned stored procedures. So SQLite doesn't have the concept of stored procedures per se, but it does have this thing called prepared statements. And what that does is it allows you to, instead of specifying a value to go in something, you specify a variable. And then you bind a value to that variable at a later time. Now, you know, that may not sound particularly useful, but it has 2 really important functions that I'll talk about a little bit later in more detail. But one is it prevents SQL injection attacks. You'd only get that in very specific circumstances on with an app. And the other thing it does is that it actually can speed things up if you're actually going to be using the same statement over and over again. So, for example, say you're going to put 1,000 records into a table. Instead of saying, okay, I'm going to build each SQL statement itself up, use a prepared statement and just bind the values, just iterate through them, each time binding the values, and that's much, much faster. And I'll explain a little bit why that's faster a little bit later. But what you do is, the first thing we're going to do is, again, we're going to use transactions. A transaction allows you to, and again, this is the speed, but which I'll talk about later. But what a transaction allows you to do is say, hey, group all of these statements, all these steps in one thing, and then commit them at the end. And if something goes wrong, you then have the choice of either saying, commit all the data, so it updates the database, or with what it has, or roll it back and say, don't do any of it. So it gives you that control. So you might say, hey, I want to put these values in to my database, but they're interrelated. And if something fails, I don't want any of them to go in. And that's what a transaction allows you to do. So we're going to begin the transaction. Then we're going to do this command here. This is the SQL we're going to be running. So insert into the employees table, values, employee number, first name, last name, rating, just as before, values. And then we're going to put variables. And we specify their variables by putting this @ symbol in front of them. And we prepare the statement. And we're only preparing it once. And now we're going to go through some information. Okay, so that I've already put in, and I've already populated in a directory I pre-prepared, and we're basically going to bind that value. So we're going to bind this variable to a value, this variable to another value, and so on and so forth. And then we're going to run. We're going to execute that statement, that SQL statement. And if you look at the result that comes back, it says that it's done. So it says it's inserted something correctly. Then we have to prepare the statement again. We have to basically tell it to clear the bindings and reset itself. And now it's going to go and bind more data to it. So it's just going to keep binding information, but we're not preparing that statement again. We've only had to prepare it once. So it's much, much faster. And then at the end of it, we're going to commit that transaction. So it's just commit transaction, and we run that commit statement, and then it will update the table with all that information that we've just prepared. And in this case, it's going to come back and tell us it did three insertions. Number of rows inserted was 3, which is what we were expecting in this case. So let's take a look at the contents of that table again. So now if we look at the cursor, so that's the list of objects, we can see that there's 4 rows in it. And each one has different information. So it correctly did it. That works. That's fantastic. So we're going to insert record into the second table here. And we're actually going to try and insert so we're going to insert into the second table an employee number, an asset number, and these values. And there we go. And it inserted it. Great. Now we're going to turn foreign keys on. One of the things with foreign keys is by default, they're not activated. So even though you specify a foreign key constraint, SQLite won't implement it. It will implement it, but it won't enforce it unless you actually turn the foreign key constraints on. And you do that by a pragma command. Go to definition. Come on. Go to declaration. There we go. So basically, pragma foreign keys equals on, or pragma foreign keys equals off. And if you want to know what its current setting is, you would just run a command that said pragma foreign keys, and it would come back with either 1 or a 0. So we're going to turn them on. And now we're going to try and insert something that is going to fail that constraint. So we're going to try and insert this. Come on. Oh, come on. SQL command. There we go. So we're going to now try and insert into this allocated assets table the values of 1, 2, 3, 4, 5, 6, and 1, 1, 1. Well, there isn't an employee number with that value, and we've told it that this table can only hold rows where the employee number exists in that employees table. So we run the statement, execute the statement through that step command, and now the result that it brings back actually is constraint, which tells you that it's failed a foreign key constraint. So it doesn't allow us to do it. That's the fail. Get table contents. Let's insert a bunch more records in there. Take all these out because we've already looked at this. So we've just inserted 6 more records. So now let's just have a look and see what that table now holds. Come on. And we can see it now holds 7 rows of information. Each one's different. But that one that failed doesn't exist. It's not in there. Okay, so now I'm just going to do a couple of quick more queries for you. I'm going to show you how to get a record that matches a particular criteria. So what we're going to do is we're going to bring back the first and last name. So we're not going to bring back everything. We're going to bring it back from the employees table where the rating is greater than 9.6, and we can order it by the last name. and it's run in exactly the same way as all the other queries were. We're going to bring back that information into this structure, this list of objects. Come on. And we can see it's actually brought back 2 rows, Richard Feynman and Stephen Hawkins, because they were the only one I gave a rating of greater than 9.6 to. So they did that great. But you can do more than that. You can say, hey, I want to bring back information that exists in multiple tables. And this is the sort of thing why using, you know, SQL is powerful, because you can actually transverse the relationship between tables and run queries that are structured around the information in multiple tables. And you can do that in various ways. So the classic way of doing it is through joins. So we're going to use an inner join here, something called an inner join. And let's pull up the query so we can look at it properly. So we're going to do a select first name from the employees table, the last name from the employees table, and the asset number from the allocated assets table from the employees table interjoined with the allocated assets table. And we're only going to put it out where the employees number exists in both. And we're going to order by the last name. Well, in this case, we already know that all of them are going to exist. So that's sort of a little bit superfluous, but you have to put it in there for it to work. Run the query just as before, and now you can see it's pulling out the first name and the last name and each of the asset numbers. So we've pulled information out of more than one table, got it all back at the same time. And we can do it a little bit more, make it a little bit more complicated as well. I mean, we can make it as complicated as we like. But for example, in this case, let's just show one more example of this, where we're going to actually do another thing here. Instead of writing employee table, assets table all the time, we can actually assign something to it instead. We can say we're going to call it E and A instead. And what we're going to do is here we say employees table is E, and we're going to join it to the assets table, which we're going to call A. So now it knows what to do. And we're going to do it where the employee number in both tables equals the same, and where the rating is greater than 9.6. This time we're going to order it by the last name, but we're going to make it descending. And if we look what it brought back, now it brought back only 4 records, 2 for Stephen Hawkins, and 2 for Richard Feynman, because they were the only guys that had a rating of greater than 9.6. And there were two assets allocated to each of them. So you can see that, queries can be very, very powerful. And you can do things using SQLite PCL, which you just wouldn't be able to do with easily with SQLite.net. You can do these complex queries where you have, multiple interacting criteria for the information that you want to pull back. You can pull back the number of records by this statement, select count, bracket star from a table. And well, that will actually bring back the number of records, which in this case is 4, which is correct. So let's delete a record. That's the next thing you're going to have to be able to do. You want to be able to get rid of information when you don't want it there anymore. So let's go to the declaration you need to do that. So you can do a delete statement, delete from employees table where first name is Richard. And it's as simple as that. We prepare it, we run it, and it's come back and told us, yes, Ah, no, sorry, haha. It's going to come back and tell us it failed. Could anyone tell me why that failed? Foreign key. Exactly. We told it that this allocated assets table can't have anything in it if it doesn't exist in the master table. When we try to delete a record out of that employees table, that master table, it would have left an orphan sitting record in there that failed the constraint. So it said, no, you just failed the constraint. Well, there's a way around that. We're going to turn the foreign key constraints off.
Is there a cascade option?
Yes, there is. So now we're going to delete it. And this time it has, and it says, yeah, I've deleted one row out of your table. And we can prove that by seeing how many records are in there. We'll run that exact same query again. And it's come back saying there's 3. So we did delete a row out of there successfully now. So the other thing you might want to do is delete a table. So we're going to delete this allocated assets table. Now, if we tried to delete the employees table while foreign key constraints were set, it wouldn't let us because it would obviously break the constraint. We turned it off so we could, but we're just going to, even with that foreign key, we could delete the allocated assets table because the constraint's going the other way. And you do that by using this drop table if exists statement. We're going to run it. It comes back and says the result is done again. And it's been deleted. And we can prove it's been deleted by running that query we did before to get the tables. And it's come back and it said now there's only a count of 2 instead of 3, and the only table we've created that's still in there is that employees table. It got rid of the other one for us. So the last thing I'm going to show you how to do is how to delete a database. So you've had a database, you've decided you don't need it anymore. So it's a temporary one or whatever. First thing you need to do is you have to dispose of it. Now, in Android and iOS, the SQLite implementations in those assume that if you're deleting it, it's going to dispose of it anyway. So as part of that process, SQLite will actually do it. The Windows Phone implementation doesn't. And it will actually throw an exception if you haven't disposed of the database previously. Oh, sorry, the connection, not the database, the connection. So if you've got an open connection on it, Windows Phone will throw an exception. Android and iOS won't. They'll close all connections. They'll delete the references to all connections for you anyway, as part of what they do. Windows Phone won't. So basically, you have to try and do that. And so you just dispose of it. If there's nothing open, it doesn't matter. I put a try catch around it just in case it's going to throw a problem. And then to delete a database, what do? You just delete that file from the file system because it's all stored in a file. So it's really easy. You just delete the file from the file system. And we can show, when we look at the file system to see if it exists, it's false now. So we deleted the file. So that database no longer exists. Let's go back to the presentation. Okay. So you can see, I hope from that, you can see that, you're writing SQL queries, your SQL statements. It's really easy. You can see, because you can actually look at the SQL that's being executed, you can figure out what it's doing. If you've got a problem, you don't have to go through loads of code to figure out what's going on. You can look at the SQL statement. So it becomes very easy to debug those statements. And if it isn't doing what you think it should, you just go on a Stack Overflow and find out what you're doing wrong. What's wrong with that statement? And you'll very quickly find that you can solve your problems and debug what you're doing. Okay, so a couple of security tips. first. Somebody already mentioned SQL injection. So SQL injection is the most common form of database security attack. It's the most common attack vector for a database. Okay, so there's some things you should never do. You should never send SQL from one service to another to be executed. Now, typically, SQL injection usually happens on things like web apps, or when you're sending something to a web server to be executed on the database. Well, in an app, you could do that. You could have a web service that expects you to do that. Never ever do it. It's bad, really bad practice, and only bad, in my opinion, bad developers will actually subject their architecture to something that's vulnerable to SQL injection. The SQL could be spoofed. That's what it does. What it does is it actually says, this, I'm going to put something in there that's going to make it allowed to be executed, but it's going to do something different to what was intended. Never send SQL to be executed from an app to a server, or the server to an app. Always use a command response protocol. So always use something like RESTful services, or construct the SQL locally through those. So, don't say, hey, I want this information, so I'm going to create this SQL command for you to run. You give me back the results. You do a RESTful service and let the RESTful service implement the SQL for you. Okay, no problem. Now, where SQL injection is a real possibility in apps, really, is where user input is used in a database query. And the prime example of that is a login. So let me give you an example of something that could go wrong. Get an entry of David in a login form, right? This might result in this statement. Select password hash from users where user or user ID is David, and then you execute that. Okay, fine. That's sort of a standard sort of login type thing. Yeah, no problem. Okay, but what if instead of putting a user name in, right, the attacker knows the username, so they put David apostrophe colon update users set password hash equals 1234 where user equals David. Well, now when it runs this, it's actually running select password hash from users where user equals David, great. Update user set password hash 1234 where user equals David. So now that will set the password hash to a known value, which means that an attacker can now get in. They know the username. They know what the password is going to be now, because they know what the password hash is going to be created, because they've generated that in advance, and now they have access to that account. So you can stop that really easily. So the first thing you can do is pass the entry to restrict the input of certain characters, such as spaces, commas, colons, things like that. So you do a bit of pre-filtering on the field. And the other way will be to use these prepared statements that we showed earlier. Because what the prepared statement will actually do is it will actually, when this comes in, it will actually won't allow all of that to get run. It will actually break it down and actually end up resulting in an exception, which you have to obviously have to trap. So now let's talk about performance. We've got 10 minutes. So the thing with performance is there isn't a one solution fits all when it comes to performance. Depending on how you're using the database, it depends on how, it's gonna vary how you're going to want to tweak it to optimize performance. And the default configuration is going to be fine in almost all circumstances that you're going to come across in an app. You're only going to really find performance issues where you have, very complex database with lots of interrelated tables, where you have a lot of data. I told you about a company that I talked to 2 or 3 years ago, who literally had hundreds of thousands of records, right, in their local database sitting on the phone. They were doing searches in it, and lots of searches through that information. But there are some some practices that you should follow if you want to keep performance in mind, and one or two things that you can investigate if you find you have some performance issues. So what should you do? Well, run the database access and operations as async await methods or in a separate task thread or thread pool. Right? Avoid synchronous operations. It's accessing the file system, so it's going to be relatively slow and it will block your GUI thread. So do it in the background. Utilize transactions for multiple dynamic statements. We talked about that, doing that a little bit. And utilize prepared statements for repeated operations and use indexing. So you should always be doing those sort of things. If you still have some performance issues, then you could try modifying the schema, so modifying some of the setup. And you could consider adjusting the configuration via pragma. So, sorry, with the schema, I mean, you could split tables up. You could change the relationship between tables to try and increase the performance. Sorry, or you could change the configuration of the settings of the database. So let's have a look at why transactions can increase performance. Okay, so by default, SQLite wraps every single statement that's executed in its own transaction. And that carries an overhead, that takes time. So if you're doing a lot of queries, a lot of statements, have each one go through this process of wrapping it in a transaction, running it, and all that sort of thing in the background, it's going to take more time. So you can manage your own transaction around groups of commands, groups of queries, and then mark them successful. We showed how to do that in the code that I showed you. And if you don't want to change it, if something goes wrong, you can do a rollback command. Or there's actually an easier way. If you don't need transactions, you're like, yeah, this is just a pain in the ass. I don't want to be bothered by a transaction. You can turn them off, right, by using a pragma statement that turns off the transaction journal. If you tell it not to use a transaction journal, it can't use transactions anymore, and it won't do that wrapping. And as I mentioned before, prepared statements, I mentioned that it improves performance. Okay, so if you have multiple statements to execute, and they've basically got the same format, you're trying to do the same thing, but it's different values, different information, different data, use prepared statements. Okay, so SQL is going to pass the statement before executing, as we showed. We prepare it once. Okay, it's going to prepare each one once. It parses it and works out what it's going to do. It's called a commit plan in database parlance, and it can take a little bit of time to do that. So if it's doing that for every single statement, every single query, that takes time. It may not be necessary. By using this prepared statement that we saw, you only do it once, and then just change the values that are being pumped into it. And this is just how you did it. You saw in the code exactly how to do it. There is one little thing that's in here. When you're binding data, you can either use this @ symbol, or you can tell it to do it on the first or the second or the third value that's in there. I do not recommend this, although it supports it. Again, it's not good for maintainability. You want to be able to say, I know the variable name. I can guarantee where it's going. So when you use prepared statements with transactions, you're going to optimize the performance of your inserts and things like that. We don't need the code examples. We went through them already. You'll be very pleased to hear. So other performance tips. Well, you could use multiple databases in your app. Why would you do that? Well, you might do it to avoid locking issues, to allow multi-threaded writes, for example. But when you do this, be careful that you don't overcomplicate things. And be aware that SQLite doesn't support triggers or queries across databases. Some database engines do. You have two separate databases, and you can say, hey, use this database for this, and then inject that information into this, a query into this database, and it will do it for you. You can't do that in SQLite. Avoid multiple connections to a database. That can be very bad. You can get all sorts of unforeseen consequences from that. But if nothing else, there's an overhead, both in memory and speed, each time you have a connection to a database. Now, if you really don't want to have to open up a connection each time you're going to access the database, You could maintain a persistent connection. You basically implement your own database connection manager and say, hey, I've got this database or these 3 databases in my app. I'm going to open up a connection to each one, and I'm just going to use that connection everywhere. And at the end, when the app comes out, or at some point in the future, I will, you garbage collect those, you dispose of them. Use indexes when creating tables. Use obviously the primary and unique, or create index commands to do that. It will speed up your queries massively, especially if you have a lot of records in there. Use SQL statements to filter data, that your query data, rather than code. Don't bring everything back and then go through the code to filter the data. Use SQL's inbuilt commands to do that. If you've got very large tables and you've got problems, consider splitting them up. This is a form of denormalization. Okay, so say, for example, you have employees and you have 500,000 employees. And you might find it taking a long time to go through that table and search information through that table because there's so many entries. You could say, well, okay, I'm going to actually split it into 4 tables. And what I'll do is I'll direct my code, I will direct which table to look at, depending on the last name of the employee that I'm looking at, or the value of the employee number, or whatever whatever you're going to be using it for. Again, it's one of those cases where you don't do it if you don't have to, but if you really find that table's going too large and it's for your performance, you can look at ways of breaking it up. Yes.
What is this as a table that is optimal for SQLite or for performance?
That I honestly can't answer that question. I mean, the optimal performance is when you're not seeing any real noticeable degradation in the user experience of your app. And that's going to vary between device to device, the table structures. So that's an almost impossible question to answer.
These are standard consulting.
Yes, kind of the same with
SCA.
And if you really have, for example, if you've got a lot of information and you've got problems with storage space, consider compressing the data. Yes, it's going to make access slower because you're going to have to compress it before storage, decompressing it after you pull the data out, but you will save memory. So, you could consider doing that. And of course, that last one, as I said before, avoid synchronous access to information. Okay, more ones. So use limit equals 1 when querying for checking to something exists. Don't pull back loads of information. Just pull back one record. It's much faster. For large, complex, nested queries, consider breaking it up and using temporary tables to sort of intermediate data. So instead of having this really, really long query that's basically running selects upon subselects upon subselects and things like this, create temporary tables and basically do the selects, create a table, do the selects on that table. It ends up being faster. For large databases, you can compact them using this pragma command called vacuum. Okay? And what does that do? Think of it as like defragmenting the database. Databases, SQLite included, basically stores things in pages of information. And if you delete things from those pages, it doesn't squeeze them together. Those bits, if you like, those slots where that information can exist, basically have nothing in there, but they still exist in memory. That space is still being used. It's been allocated. So you can use the vacuum command to basically scrunch everything up again and get rid of that those unused spaces. And you're going to need to do that if you have a large database, especially after deleting a lot of data. If you're deleting lots of data through the life cycle of the app. You can do vacuum, you can do it manually, so you can actually say, run that command now. You can tell it to decide when to do it on its own. But when it does that, you don't know when it can do it. It's going to do that. It could do it at a time which is vital for the performance of your app. And you could do it demand-based. You can actually say, do it when the page count reaches a certain value, or the free list count reaches a certain value. And as I say, the manual one's really easy. It's just pragma vacuum, and that's it. And you run the command. But if you do it, you should always do it in a separate task or thread, because it could take time to delete. Also remember that while it's running, your database is going to be locked. You're not going to be able to do anything else with it. So another thing is to avoid glob and like statements. So a glob statement is just a like statement, which is basically, there's a couple of differences, but it's basically a like statement that is case sensitive. And what it does pattern matching on text. So it's like, you know, give me back all values that are where this field is like, you know, ABC star. So anything that starts with ABC is going to bring back for you, no matter what it is. It takes time. It has to go through, it has to pass the strings. So avoid them. Sometimes you need to, but often there's a different way of doing things. And if you're seeing performance problems surrounding strings and string manipulation, take a look at it and see if there's something else you can do. Avoid comparing length on long strings. Again, it's tricky. It requires parsing. So that takes time. Use in statements instead of or statements when comparing a single field to multiple values. So you might say, bring me back everything where something is 1 or something is 2 or something is 3. Right, those ors can take time. When you could actually say, bring me back all cases where something in and then 1, 2, 3. And that runs a lot faster in the background. Additionally, the in statement can use indexes. All statements can't use indexes. So if you have a lot of things to look for, you've got a lot of records, and that column's indexed, you can get a big performance difference if you're using the in statement to do exactly the same thing that the or statements can do. And the last thing is well, it's consider using intermediate mode for transactions if you're going to be using transactions. Immediate mode. That means basically it's going to be running the transactions instantly. It doesn't sort of block. In the background, SQLite and other databases can basically sort of decide on multiple transactions to basically commit them all at once or commit them over a period of time. It's going to be faster. Sometimes it's fast if you force it to commit for a transaction immediately. Again, you might find it makes no difference. But, you know, that's what I say. There's not one rule for all circumstances. You try these things to see if they help. So here's some pragma settings that might help as well. Again, maybe, maybe not. You could tell it to use memory for temp store. So it will always use temporary storage to store things in process. Normally, it will do it on file. You could tell it to do that in memory. It's going to use more memory, but it's going to be faster. Finding that you've got default is basically a kilobyte, 1024. Increase the flow 9 cents. See if it works, if it helps. The cache size, you can increase the cache size that SQLite will be using. The default 2000, you can increase it say to 5000. See if that helps. The journal mode. You could set it to WAL, or you could turn it off. If you turn it off, it's going to disable transactions. Okay? If you do write ahead, then basically it's going to try and predict what it's going to do. Again, it may not help, may help under certain circumstances. Locking mode. You can set locking mode to exclusive. So you can say, hey, I'm not going to let multiple things access a table, even if it's to read. I'm going to say it's going to be exclusive. Only one thing can access the table at a time. If you've got lots of things hitting a table simultaneously, you might find that improves your performance. Again, it's balancing act. You just got to see if it helps. You can set synchronous to off or normal. Count changes. How many changes have happened to a table? Well, every time there's a change, it's going to be maintaining that information. You can turn that off. And you could read uncommitted to true, which can allow you to increase the scope of your transactions, and that might help. You know, some of these have interdependencies, either in operation or in the order they're applied, and you know, none of them may. Some of them may help, some of them may not. If you're seeing performance issues. Yeah, as I said, you saw the form of the pragma in the code. It's basically pragma plus the instruction, you know, plus a colon. I'm not going to go through all those, but there's a whole bunch there of different pragma commands that you can implement. Okay, so last thing, I just want to talk about one last thing, and then I'm done. Okay, you stop listening to me droning on about databases. So one of the problems is managing database schema updates is potentially onerous. So if you have n versions of your app, then potentially you've got n times n plus 1 divided by 2 possible update scenarios to your database. And downgrade, if you can allow downgrading as well. Now, you don't know what version of your app that your user's going to have when they're updating. So you've got to test every single one of these. They might be going from version 1 to version 2, or they might be going from version 1 to version 7, or version 6 to version 7. And you've got to test each of those upgrade paths. That could be a big problem if you've got a lot, you know, if you're adding features, adding functionality, so you're changing, you know, the data and the tables in the database within each release. So I've got a strategy that I'm just going to suggest to you for managing that complexity. Okay. So first of all, you can always set the version of the database using the pragma. So every time you change the database to a particular version of your app, you increase the version of the database, and you can pour that out. Then create a script for upgrading the database as part of your initialization. When you it's part of the initialization when your app first runs. For upgrading it from version n to n plus 1. So from version 1 to 2, from version 2 to 3, from 3 to 4, and so on and so forth. And those are the only scripts you need to then actually write. And then do the downgrade as well if you're going to support downgrading. And you're going to test those. But now you're only testing each one. Then what you can do is part of your initialization, you just call each one in turn to go from the current version of the app to the final version of the app. So if you're version 6 and you're going to version 7, you just run that script. If you're going from version 3 to version 7, you actually run 3 to 4, 4 to 5, 5 to 6, 6 to 7. You can tell what version you're at of the database because you can pull the information out using this pragma because you're always updating. Each time you've got a new database schema, you're giving it a new database version that's embedded as part of the database. So now you're only going to have to test n upgrade scenarios, not n times n plus 1 times 2, which is divided by 2, which is a lot. You've decreased the complexity. It is slower. It's going to be slower when you have to upgrade from multiple versions, but you've decreased the amount of work you have to do massively. And also, you're going to have to store those scripts as part of your app, because when your app when version 7 gets installed, you don't know what version they're currently running. Okay, and that's just a sort of example of what you might do to upgrade, to update a scenario. Now, as I said, a structure. As I said, SQLite doesn't support auto table. Okay, well, it does, but in a very, very limited way. You can do things like change the column names and stuff like that. It's not very useful. So the way you do it is you create a temporary table, the backup, and then you back up everything that's in the current structure into that temporary table, then delete it. Then create a new table, which has the structure that you want. Then insert everything from your backup table into that new table. Then delete the backup and commit it. And that's sort of, that approach to doing it is basically the way that you update the schema of your database in SQLite. And then if you have, as I said, if you have one of those for each of the versions, it means that you'll be able to handle any updating from any version to any other version in a very manageable way.
Are there tools to help this sort of thing? Visual Studio Database projects for SQLite or directory tools?
There might be. I haven't come across. I certainly haven't used any.
That's kind of hardcore. Right?
Oh no.
You got a trivial example there. Still,
Yeah. That's true. And I don't know. There may well be. Okay. So that's it. Any questions? I know it got sort of a bit dry and a bit in depth in places, but hopefully it's given you some ideas. Yes, it is. Hopefully it's being recorded.
So you guys can post it on.
Yeah, we'll put it on the site. Just so everybody knows, we try and record all the presentations and then put it on we've got a YouTube account feed, whatever they call it, and it gets put on there through Google Hangouts on air. And it's accessible throughout the Meetup Group's Google Plus page. So if you go to the Google Plus page, you'll be able to see all the recordings, all the presentations that we've done. You can go through. So you're probably going, I hope I never see a database again. But is there anyone got any questions? Okay, thank you. Don't be scared of databases. They're easy to use. You just have to figure out, how you once you start using them, once you start using SQL, it's really, really easy. As I say, has anyone used SQLite.net? Do you want to say just give people a few words about your experiences with that?
Yeah, SQLite.net is just it's a nice .NET wrapper for a lot of the things that you've talked about here. So it uses some link type extensions in order to do queries with, and provides some of those asynchronous wrappers that you had written yourself, which is packaged in with it. So it's a great tool for getting started on that quickly and easily. And it's well documented as well, so you can look up pretty much anything about it written by the author. So.
There's one thing I've got to say about this SQLite PCL library. There's no documentation on it, none whatsoever. It's horrible. The guy went, well, I've just basically put the C++ methods in C# backers, so look at the C++ documentation. So it's a little bit, it's a little bit bad from that way. But once you understand how it's working, you can just use, SQL. So once you're running SQL, there's loads of information out there about that.
Question. So this is a mobile database.
Yep.
And there's a server database. How do we access the user's information? Like create a video game and want to find out more information. The user, how do you access that on the phone? Or you can't.
To get the user information out of the phone.
Yeah.
Well, that's going to depend on the phone. It's going to depend on the operating system, whether they allow you access to that information. You can certainly leave permissions. So in Android, iOS, my guess is they probably wouldn't allow you as an app to get hold of that information. Android is Wild West, so generally speaking, you can. You just have to ask the right permissions. don't know where specifically they store that information. You have to look that up, which of these platforms you use.
It's like, well, default menus are pretty neat. You want me to use it. What do you want? Scheme that.
Right.
How we use SQLite to use that for many things. And for all three platforms. So I think it would be pretty easy.
Engagement is going to be good. If you're storing whatever, like information, scorecard, whatever, that's very open stored. There's things to get afterwards. Whatever. That's going to have to figure out how to do that in the cloud. Whether so on the cloud, or whatever it might be, that you can sit back. Yeah, you can do it. I mean, you're syncing. If you're talking about syncing data between what the data is stored locally, the data is stored remotely, you can either come up with your own syncing process and how to manage that data and keep it track. But there are some databases out there that will do it. Couchbase, for example, were involved last year, and that's one of the services that they provide. They use SQLite in the background. Actually, no, I don't think they do. I think it's their own. I think it might be their own database actually they use, but they can run on the cloud and on the device. And they can for you.
Yeah, it's for the most part, you use SQLite for particular purpose, which is that you have table type information, that has field, that has constraints, and there's different ways to put those tables. And in your case, you're looking for a functional piece of information. In code that you have that is when you're writing the app, you can extract that information in some way and share it in some way. You don't necessarily need to go through this the overhead of creating that SQL table and figure out how to extract it and add script.
Another one people ask about often is encrypting information. And SQLite doesn't support encryption on its access mechanism. It's not as part of it in their policy SQLite standard. You can, for example, because it's a file, a single file, you can encrypt that file, but then you have to go through the process of encrypting and decrypting time and stuff. Or you could encrypt fields, you say, hey, this information, and you encrypt it before it goes in. There are a couple of paid implementations out there that basically provide you that functionality. Put a wrapper around it. Crypto. SQL crypto. Oh, no.
Can you still search for? Can you still search those looking for?
You can't.
Yeah.
So you can encrypt it. Values.
In other words,
You can actually get the password.
Yeah.
So it should not be in there.